Okay, let's review what we just took in the previous videos about charge conservation. We said that if the charge inside a volume, a closed volume, changes with time, then it must be the case that charges are going through the surface, and so there must be a current going through this surface. So a current resulting from charges going through the surface. And the relationship between the current and the rate at which charge is changing inside the volume is given by this equation. Now, we said also that in steady state, very special condition of steady state, the amount of charge inside the volume doesn't change with time. That's what steady state means. That means that the total current through the surface should be zero. The current going out should be zero. Let's apply this for a junction. A junction is a place where the wire splits into two parts. So if we look at this closed volume, the closed volume consists of this surface plus the wires plus this surface plus all the wires, all this closed volume inside here in this region. If we're in steady state, remember dq in by dt is zero. The amount of charge inside this volume cannot change with time. That means from the conservation of charge equation that integration of j dot dA through the closed surface is zero. And remember, when you have a closed surface, the area vectors go from inside to outside. So that's why the dA vectors are the way they're shown here. So let's look. Well, the only places where the charges are going through the surface, through the closed volume, is on this surface and on this surface and on this surface. So you have three terms for this. There's no charge going through this part, the actual wire surface. No, it's only going through this area, and this area. So integration of j1 dot dA is the current going out over here. Integration of j2 dot dA is the current going out over here. Integration of j3 dot dA is the current going through here. Now remember the trick we showed, the relationship between I out, current going out, and current going in. It's just a matter of taking the area vector. If you write this area vector as minus times an area vector going this way to the right, then in that case we can write I out at 1 as minus I in at 1. Where I in at 1 now, we take this area vector, not the other one. So there's a minus sign between these two things. I out and I in, there's just a minus sign between them. So let's keep this now as minus I in. So we replace I out by minus I in. This result, so minus I in plus I out 2 plus I out 3 is equal to 0. If we just rearrange the terms, we get this equation for the junction rule. The current going in to a junction is equal to the sum of the currents going out of the junction. And this is a result of the fact that no charge can change, the charge cannot change inside this closed volume. In steady state, the amount of charge inside this closed volume cannot change. So the only way is for the current going in to equal to the current going out. No charge can build up inside this volume, or no charge can decrease inside this volume. It always stays the same.